Let me introduce myself. My name is Irina Kamalova. I'm senior software engineer for now. I work at Solr Technology. It's financial data services, and I would like to tell you today about triangle of Cassandra, Solr, and Kafka. So let's start. Motivation of this talk is to give you a brief introduction to Apache Cassandra. It's very popular NoSQL database, and it's becoming more and more popular, even if it appeared a long time ago. Then I will give you a brief introduction to Apache Solr, and then I give you example of integrating these products with Apache Kafka. So I would like to start with business case because frameworks always here for solving some business tasks. And my business change will be the problem of tweets. So tweets is about, they trigger about 5 million events per day. It's really huge load. And if you want to store it, we need to store tweets somehow. We also would like to verify this tweet somehow. And for verified tweets, we would like to do some analytics, business analytics on this. Yeah. So here is Cassandra coming like solution for this problem, because Cassandra is really good for huge amount of writes. So we want to write for a lot and a lot of very fast on very high speed rate. So that's why we can start with Cassandra, and we know that yeah, so Apache Cassandra is good solution here. What is features of Cassandra? So features is peer-to-peer architecture. It's a popular architecture when you have not master and slaves. The master perform as units that responsible for writing data, and slaves responsible for reading data. Here we have peer-to-peer architecture. So there is no master and slaves. All nodes equal with each other. That's why it's easy to scale cluster of Cassandra. You can pick up replication factor. So you can say how many nodes should store your data. And that's why Cassandra providing very solid data durability. Next, this is fault tolerance, and this provides high availability. So high availability and fault tolerance because first of all, replication, and if one node fail, you can just query another node. Also peer-to-peer architecture lattice, because there is no point their master failed. And you can easy scale cluster. So scaling cluster is coming without downtime. That's why rate of high availability is very high. You also can provide replica in different data centers, and it's very easy to add new nodes. That's why we say that Cassandra have elastic scalability. One more feature is tunable consistency for reads and writes. So there is no restriction for you to say how many nodes you want to store data before you are going to read data from these nodes. And the same for writes. So you can say, okay, I want to read data that inside two nodes, at least two nodes, and I want to write data for at least 4 nodes. Default policy for consistency is local quorum. That means here, for example, you have 5 nodes, and for local quorum, you will wait at least 3 nodes respond that they have this data, or if you write this data, at least 3 nodes will respond that they written data successfully. Column-oriented and schema-free. So that means that you can add new fields in your columns, even if you have already run an application in production. You already designed schema, but you want to add new fields, and you can do it. You can alter this table without any data migration. And I would say almost schema-free, because there are a case when you can't add new column, and I will tell about it a little bit later. So, yeah, here. This is NoSQL solution, and it means that it's great scalability, but you will miss about some features. So first of all, Cassandra means no joins. And we will look at architecture to understand why. You can't, you now need to denormalize your data, because you can't query data and then join another data from another tables. You need to design your model very carefully. The second thing, no subqueries for selecting data. So when you want to do some queries like select something that contains in another table, you just can't do it. There are no queries with like expressions, and you can't use regular expressions for selection data. There is no commit and rollback features. That means that before, if you have before the Cassandra something like complex transactions, then you needed several operations, you can't do it anymore. There is some term that's called light-based transaction, but that's not true. It's not transactions as we used to think about in relation database. So you can't create several steps and wrap it in one transaction. And as I said, it's schema-free and you can add new columns, but it's not possible in some cases. And some cases, if your column is primary key. If you need to add new column that need to be primary key, that's responsible for unique of the data in your column, that means that you need to change your model. You need to change the tables that you want to add new column, and you need to do full data migration. Everything's the same that in relation database, you need to create new table, you need to drop old table, and for primary keys column, you can't add new columns. But if it's not primary key, that's okay. So why it's so difficult for joins, for subqueries, for like expressions, and for transactions? Let's look at the architecture of Cassandra. So as I said, there is no master slave, and every node is equal. But if you start to use with some query, any node could be picked up from the client. Client is your application that use drivers to connect to Cassandra. So client pick up some node, any node. It could be node 6, node 1, node 4. So in my example, it's node 4. When client pick up the node is performing as coordinator. So node coordinator ask other nodes if they ready to provide data. If you have policy for reading, for example, it's enough for me to read only from one node. It's very fast operation to read data. The same to write data. You just write for coordinator. If you have some replica, the coordinator will ask for node 5, for example, also write data, and is going to wait for node 5 to respond, and then said, okay, write was successful. Well, if you want to say feature with join operations, that means that for any node, we need also query other nodes for data to join them. And that's becoming very huge and heavy operation. So you can't do these operations because it will be very slow. You need to ask every node about their data to join it, to use regular expressions, to use some subqueries. Now, that is not going to happen because it's too heavy. Instead of it, when you query data, you have primary key, and it's compute primary key, and it's pick up correct node to retrieve data. And it's very easy and really fast. Next, as I said about lightweight transaction. So what is it? Lightweight transaction, it's when you want to do something, something like if exist or update with if conditions. It's also very extremely expensive operation. Again, to do this operation, if not exist, coordinator need to ask any other nodes if in their data, some data is not exist. That's why inserting becoming very heavy operation. You still have it. It's allowed to do. It's called lightweight transaction, but the truth that it's not light, and it could cost you for big timeouts on production. And the same for update condition. It's the same case, and it's also called lightweight transaction. It's not lightweight at all, and it's extremely expensive. So I would suggest just forget about this operation and never use it. So why lightweight transactions are not lightweight at all? One more thing there is Paxos protocol. When we want to update data on several nodes, for these two operations, Cassandra under the hood use Paxos protocol. How does it work? Paxos protocol is work then leader asks replicas to prepare data. Then replica return response to leader and say that they are promised to save data. Then leader do propulsion. Propulsion means new update data, and then replica should accept it. So there are 4 steps. And in Cassandra case, it's even more steps because it also have to prepare, promise, propose, accept, and also it's in prepare it read, in promise it's return result, in propose it's commit, and in accept it send acknowledge that okay, data is accepted. And that means that we need to do 4 round trips across the cluster. So we need to go through all cluster, and it's 4 times. That's why if you use this lightweight transaction, you can end with timeouts. Well, okay, this is what I need, but what if I need more complex query on some data? I can't use feature with regular expressions. So what should I do? Well, here is solution. It's Apache Solr, and it's based on Lucene index. Basically, Lucene index like a fundamental engine to provide a complex query and analytics on text search. And Apache Solr is simple solution above Lucina. There one more solution is Elasticsearch. In this talk, I will talk about Apache Solr. So features of Apache Solr: full text indexing and search. You can put data there. You can create a good schema that needs for your regular expressions, and there will be full indexing search on your data. The next thing, REST like HTTP or XML or JSON API. Very simple API. And you can use other features like statistic on your data. You can check how many times some basic words appear in your data. And one more feature of Apache Solr that is well documented, it's Apache product, and you can find almost for any question, you can find the answer in documentation. It's have great descriptions. Powerful UI, I'll show you. UI for Solr is very beautiful. You can just install Solr and try it on your own. When you install it and you start Solr, even one node, it's started on your local host, and you can see data, and you can add data in collection, and you can search for them. On this example, I put 3 tweets in this Solr index, and I say, okay, give me all data that contain word Google. I put there three tweets, and for these tweets, there are tweets with Google, and it's found it. And for me, it's just needed to say text that is filled should have the word Google. So regular expression on Google, any symbol around this word, and it's pretty simple. You can also do some filter queries, some sorting, and there is a lot of things that are possible to do. And it's very easy to learn how to work with it. The next thing, next step for Solr was to create Solr Cloud. So create cluster solution. And it has the same powerful features that have in Cassandra. For example, peer-to-peer architecture. That means that you have no more master-slave architecture, but nodes are equal between each other, so you can query any node for data. And that's also mean fault tolerance, because you can replicate data, and even one replica failed, you just go to another replica and get data from there. You can use Zookeeper for central configuration for the entire cluster. That's why I bring this guy here. So it's an icon of Zookeeper, and a lot of companies already use Zookeeper. So this is a pillar solution. And you can just use the same Zookeepers that you already have in your system to install Solr Cloud and manage entire cluster from Zookeeper. Automatic load balancing. What does it mean? It just means that you don't need to create your own balancers. You just get it from Java API, from library, and you can use it. And you don't worry about balancers. It have different balancing under the hood, so you can easily start to work with it. Failover for queries. It means that if query failed, client wouldn't be client would still running, and that's very gently handling errors. Yeah, and as I said, Zookeeper integration. So if you already have Zookeeper, it's easy for you to start to work with Solr Cloud. And for Solr Cloud, there is as well good UI. So it's easy to maintain and manage this cluster. Yeah, this is Solr Cloud. So it's enough to, so it's very easy to start to work with Solr. You just create Solr Cloud on your machine, and it starts 2 nodes on, for example, 8983 and 8984. And you can look at these nodes. In here, it's even only 1 node cluster. It's created 1 node cluster for me. And you can see already some basics metrics, CPU usage, heap usage, disk usage. And I think it's very powerful. So, well, this is what I need, because I can write at huge rate, and I can read data with complex queries. How to integrate it? So my first idea is just to write application that will store tweets, and then I will put it in Solr. So why not? We at least one problem is resolved, verify tweets. Okay, we can implement something on our side. And indexing seems like it's also will be resolved, but in this data flow, that seems very easy. We just have tweets, we put them in Cassandra, and we verify what is valid and put in Solr. And what if Solr is not responding? We can't say this client that, okay, wait, I don't have running Solr right now, so I can't accept new tweets. That's not a good solution for us. And we can't lose data. We need to store it somewhere. So how to handle this case? Here, I would suggest to go with Apache Kafka. One more Apache project, and very powerful. So let's look at this deeper. What features Apache Kafka have? First of all, it's event-driven architecture. So it's very powerful to use for cases when you have a lot of events. And here is the case for this business case. Yeah. And then it have high throughput. It's fault tolerant because, again, you have Kafka cluster, and you can create several brokers, and the brokers will be responsible for storing your events, storing your messages. Yeah, so it's provide high availability. You can replicate your messages between brokers, and if one broker fails, the other broker spin up as master and provide data. That's why you also have data durability. You can say how long data should be stored in Kafka. Default value is for 1 week, but you can play with that value. And the elastic scalability means that you can add more brokers if you want. And all these things could be managed by Zookeeper, the same Zookeepers that work with Solr. So Kafka architecture is, again, Kafka cluster that have several brokers, and on top of it, Zookeepers that manage proper work of cluster of all these brokers. And your clients are producers that push messages and consumers that consume messages. And one more feature that you can create several producers, and also you can create several consumers, but consumers could be part of one consumer group. In this case, you define how many partitions your topic have. And for all of these partitions, you can do consumption with consumer group. And there, in this case, consumers acting as consuming in parallel all data. So you can scale your cluster not only with workers, but also with this concept of partitions. So for example, you have 8 partitions. That means that you can scale your consumers up to 8. You can define 8 consumers that in parallel will read data. So as I said, what's happening if one worker fell down? First of all, we have here the zookeeper who is responsible to manage all our workers. So worker can decide which worker, zookeeper can decide which worker will be leader for which partition. Yeah, so here we have a topic with 4 partitions. Worker 1 is leader for first partition. Worker 2 is leader for partition 0 and partition 3. And worker 3 is leader for partition 2. So we have 4 partitions. Again, consumers can read this data in parallel. That's why future of several partitions is very useful. And now suppose that one worker down. So what's going to happen? Zookeeper handle this situation and promote worker 2 for partition 2 as leader. And that's great. We still have our data flow. So data could be put in Kafka and read from Kafka without any downtime. And now worker 2 is acting like leader. So leader means that this worker get data and replicate it to follower. So we are good here. We can use it in our system. So now data flow looks like we get tweets, we verified them. We put in Kafka the ones that should go to our index, to our Solr. And we provide one more microservice as indexer that read data from Kafka and put it in Solr. We also can play here, like we can check if data valid in Cassandra again. Yeah, so more microservices means that we have more components and everyone responsible for their part. So this is architecture that can handle huge amount of data, and we have less failure point of failures. Yeah. Let's think about cases when something goes wrong. For example, one of node in Cassandra is went down. So we have other nodes, and even we can create 2 data centers. If even network in one data center is failed, we can go to another data center. So we are good here. It's high available. Then we can scale our applications that can handle it. We can create several nodes, and it's okay for having several producers for the same topic, Kafka allowed. And the same for this component, we can create several consumers and several instances of these applications. So even if one goes down, it's okay. It's just applications that help to go for data flow. And for Solr, here we have some fault tolerance because we can create Solr cluster. We can manage it by some nodes. If we need to scale our application, we can add more nodes in Cassandra, increase amount of partitions, amount of consumers, and increase of cluster nodes. So for some critical situation where we need to quickly scale all our system, that should work fine. Great. Again, feature of the whole system. So peer-to-peer architecture for all components, fault tolerance, high availability, elastic scalability, data durability. All components, Cassandra, Kafka, and Solr, they can provide our data durability. Fast writes, dimensional consistency, and powerful search. Oh, I hope you enjoyed it. Yeah, now I can go to questions. I see the questions appeared, and yeah, let me start to answer it one by one. In the promise a future value, in this case, what is the purpose sending to the replica? Yeah, this question is related to the slide where I yes, sorry, we'll have to go to the slide. Okay, so let's come here. Yeah, so this protocol for so leader needs to go to replica, and again, this approaches of feature value in the case what is the proposed sending to the replica. Okay, so promise is when replica say, okay, my data is valid. Yeah, what does it mean? For example, I want to put that X now is Y. Oh, by the way, I can try to use pen here. So I say that, sorry. Okay, I say that X is equal A. Yeah, and I need to prepare this data for my replica. And I know that before at every replica, the data were X equal B. Okay, that's something strange. Okay. And for example, in some case, I also come with different coordinator because remember they are equal. So for example, here I want to say X now is A, and here I want to say that X now is C. Yeah, and before it was B. And now I have like competition between them, because if this replica have B, and if this one B, but this one already C, this one can't promise that data is still valid. Yeah, and the propose will not even happen. That's why we need, first of all, promise that replica is ready to replicate data. And then we propose that now X is A. Also, we check that replica available on promise. And I hope I answer this question. Okay, the next one. Cassandra is more for transaction or for analytics? That's a good question. I would say that Cassandra more for transactions, because you put data on high-speed rate, and then you can do with data something, but with another framework. And one more framework that highly recommended to use with Cassandra is Spark. So you can say that now I connect to Cassandra cluster with Spark, and I do some analytics where I can do drawings. Yeah, I can even mark it here. So for drawings, you can use Spark. Sorry for my pen. I don't know why it's acting like this. And so yeah, basically complex drawings, merging data with each other, and then do some analytics. So Spark is your solution here. The next one, verification step is a part of business logic. Am I right? Yes, yes. It's not connected to these frameworks. I just added it for bringing this solution more like more to real life, to be more memorizable maybe. No questions, but thank you for the presentation. Okay. Could we remove Cassandra here and use only Solr as main storage? Solr is not implemented for high rate speed. And we said when we put this challenge, we said that we want very high speed rate for writing. And Solr is not good solution for very high speeds rate for writing. We also say that we want to do this analytic later, so we don't need analytics like real time. We can analyze what happened for the whole day. That's why for Solr, for this analytic, it's good enough to have eventually consistency. We don't guarantee that data to Solr come in like right away. It's not working on the same speed of data. And also that's why from business perspective, I said that we have some verification steps that, we don't put everything in Solr. We can filter some data between put it and Solr, but in Cassandra, we store in everything because we want to save all events. So I hope I answered this question. How does the partition work in Kafka? I like this question. So let me return to slide with partitions. Okay, yeah. So partitions in Kafka. First of all, you define Kafka cluster. You set, for example, 3 brokers, very good. And then you create topic. Topic will contain your data. And you say the partition factor. How many partitions will you have? So you define, for example, 4 partitions. And that means, okay, I will say from client perspective, you just know that now you can create at least 4, you can create up to 4 consumers, and they will read this partition in parallel. So consumer group is here, but every consumer can write data from these partitions. For producers, we can create several producers, and it doesn't matter for them which partitions they need to put message. Even if we have one, for example, if we have, okay, we can have 4 partitions and 2 producers here. And by default, every by default, we just will go to another partition. So the first message come to 0 partition, the second to 1, the third to 2, the fourth to 3, and then they start again by this loop. It's default behavior. We just pick up the partition that wasn't picked up before. And it's very easy to use without details under the hood. You just know that you can create several data. Also, you can define partition key. It's important if you know that how it's good to use your data to not to end up with skew. You can create partition key. Partition key that I would recommend is UUID, like global identifier, because it's guarantee for you even distribution. If you going to use just simple string for a key, it could be end with skew factor. That's why if you have unique identifier in your message, that's a good solution for partition key. You always should define some partition key. So global ID is good, like giving you even distribution for all partitions. I hope I answered this question. I don't believe that Cassandra can be compared to DMS, DB, or DB. As I said, Cassandra doesn't have features of RDMS, so it's really different solution. That's why it's very important to understand how you can use it and what else you maybe need. For example, if you want regular expression, you need Solr or Elasticsearch. If you want complex analytic with joins, you need Spark above or Hadoop above. So yeah, it's really different, and it's really different use case to use it. How do you control the rate of writes from Kafka to Solr Cloud? For example, if there was a burst of writes required and it was affecting read performance, how would you rate limit? How would you rate limit it? So as it's asking about limiting, you mean like backpressure. I hope you mean backpressure. You can answer it now. So if we try to DDoS Solr, yeah, so we're trying to write at extremely high speed. What should we do there? Yeah, exactly, backpressure, thank you. Well, I will suggest to use framework. First of all, frameworks that already handle backpressure under the hood. It's called Alpaca. It's designed to be accepted by Scala or Java, both libraries. Yeah, it has compatibility with both languages. And you can define, for example, in this component, yeah, you can define the flow that would be handled with backpressure under the hood. So if you see that this Solr can't handle such big amount of events, you just stop consuming for a while, and there is no more fear to end with out of memory error. So I would type it here, Alpaca. It's example. Also, you can look at some again solution for backpressure, like reactive Java streams, and try it, because some custom solutions, like you can control timeouts. And one more thing, I also didn't say anything about commit feature in Kafka. So when you read, from Kafka, you know the offset of topic from which topic you read data, yeah? And if you can't read data anymore, you say, okay, I'm going to hang out on this offset. And you say to consumers that, okay, this is last offset and we should stop for a while. This is how backpressure will be handled. Manually or under the hood, you just say, okay, this offset is enough. I would stop on this offset. And when I will be ready, I can consume, read data from this offset. So data coming to Kafka, and if this pauses when you can't handle events not big, it's good enough. You, for example, you can't handle everything by day, but at night you just continue consuming, and by the morning you consumed everything, and with some backpressure, it will work. Yeah, I hope I answered on this question. Yeah, thank you. Okay, have you experienced many issues with tombstones deletions in Cassandra? Have you found Cassandra requiring a fair bit of tuning to get it right? Okay, in my experience, no, but yeah, if you have some problems with Cassandra, you need to go to documentation. And one more thing that I like from Cassandra, you can come to forum and ask your questions there. And they respond quite quickly, maybe even this day, maybe next day, but they try to give you full response on your question, even without DataStax enterprise license. And I think it's very cool. Yeah, one more questions. I'm not sure if there is any real necessity of Kafka here where I can do Cassandra verification step Solr. If your system is going to survive, you can try to do this approach. But if you want to scale everything, and you know that maybe you will use, you also maybe will. One more thing here that we can use other clients. Yeah, not only Solr, but this is like architecture that can suggest you to do something in the future. So if you know that now I definitely don't want it, and you don't need one more microservice, and you're sure that everything will survive, I think it can be also tried as approach. But in my case, I started with this complex approach as I already had Kafka in my system. I hope I answered this question as well. I need to go. Thank you so much. Oh, one more. Why not write all tweets to Kafka first and then populate Cassandra Solr from Kafka? Okay, so we can write tweets in Kafka and then put in Cassandra, and then, for example, so basically Kafka could be here. Okay, I'll change it a little bit. And so yes, we can do it, but I will remain. So that's could be and probably even will be look like this. I just didn't want to put more complexity on all this infrastructure, but yeah, I agree. And it's more likely will look like this. So first of all, we write in Kafka, then we put in Cassandra, and then everything that verified and ready for indexing and maybe apply it with some filters or something else. Then we put it in Kafka again, and then we apply it to Solr. So I hope I answered this question as well.
Just to clarify this question, thank you, by the way, for a really good presentation, very interesting and very interesting viewpoint on this. So what I'm trying to get to is like, one of the common patterns that I've seen in like distributed computing nowadays is if you've got a very high event source, like lots of writes, events actually happening, you basically use Kafka as a buffer to get everything in there. And then, basically all the consumers then will be given, they can read basically at the speed that they can read at and populate them downstream. So I guess what I'm trying to understand is, in your experience, you're kind of doing Cassandra first. Is that actually because maybe Cassandra runs in memory? Like, so is it faster? Because like Kafka writes directly to the disk as well, right? So what are the pros and cons? Did you consider that? Or, that's I'm trying to understand from your experience, basically.
I definitely can answer that. You want to index only data that's already in Cassandra. That's why, first of all, you save them. Because if you will okay, you can basically create topic. If you don't need some filters that should be applied after we saved data, yeah. Again, because we have this component here as well, verification, some filters, some other steps after data saved. If you just want to put the same data in Solr, you can do it. And as I said, you want data be already in Cassandra. Okay, even in this case, you basically can put it here and then here, yeah, and you need to, here you will have one more check from this component. So if data already in Cassandra, then I apply it to Solr. And you read the same data, yeah? And if they are not in Cassandra, as I said, you use offset feature. So you said, okay, my consumer, you need to wait for some time. And then you reconsume this message again. You know the offset of the message that you need to reconsume and check if they in Cassandra. But in my case, again, I said that I want to do some filters, some check-ins, and that's why I do some preparation for data, and then prepared events, I put them in this topic. So that's the difference.
Okay, thank you. Just one final question on Cassandra itself. So how do you deal with transactionality in Cassandra? Like, for example, if you've got microservices or, basically say you've got tweets coming in, I suppose, does it matter the ordering? Like, for example, if you need to ensure one thing happens before something else, is that something you can achieve in Cassandra?
No, Cassandra is only for writing data. So as I said, even just to check if data already exists, yeah, it's a too expensive operation. Instead of it, you need to rethink your model. And for example, you need to create the same primary key. And that's, I mean, on the same data, you create the same primary key. And even if you need to add the same data, for example, again, if you read from Kafka, you probably read data because some failures. You just create the same primary key and you rewrite the same data, and it will be more cheap. It will be cheaper than check if data already exists there. So Cassandra only for writing.
Okay, thank you. Thanks very much.
Thank you.
Thanks, Irina, for the presentation. It was brilliant. So this recording should be available within the next week or two. So thank you very much and see you guys soon.
Yeah, thank you all for these questions. I really like them. I really like that you enjoyed. Yeah, thank you so much.